and welcome back to Battery Man. It's week 8 of becoming an electrician. A few weeks ago we looked at some of the tests that an electrician would carry out on a dead system, which gave us the values such as R1, R2 and Rn. This week's training reminded me why the continuity of a ring is so important. It's not just for an annual test or inspection, but it's to make sure that a circuit has been installed or is operating correctly. For example, say you leave a property that you've just installed a ring on. You plug a couple of appliances into the sockets and they work. Great, you think. It works, I can go home. Well, you could easily have a break in that ring and have not found the issue. It's only when the broken circuit is overloaded. Remember, it wouldn't be overloaded if the circuit wasn't broken. So you get a call from the customer saying that the property's burned down. Oops. This week we discovered some more tests, such as an earth fault loop impedance test and testing of RCDs. Testing the earth fault loop impedance gives us a value that we call ZE and ZS. Its job is to ensure that the property has a suitable path to earth. Why? So we can be sure that the protective device operates if it needs to, in the time that it needs to. We'll be looking at a TNCS system. We work out the ZE by disconnecting the earth from the earthing block and testing between the earth and the incoming line. Notice that this is carried out on a live terminal, but with a dead board. Okay, so we have the ZE using our testing device. With the earth reinstated back to the earth block, we now test each circuit, whether it be sockets or lights, on a live circuit. We'd test at the furthest point, or the one with the highest value of the R1 and R2 measurements for each circuit. By adding the ZE we previously got to the R1 and R2 values that we just tested, we'd get the ZS for each circuit. All these values we'd want to note down. I wonder how many electricians are recording these values with pen and paper, and how many are using things like iPads. Moving on to RCDs. Remember, an RCD or RCBO is designed to cut off the circuit in the event that the power is taking a different route from its normal one, such as through you. Note that an RCD isn't designed to stop you getting an electric shock, but to protect you from the severity and ideally death. So how do we test them? First off, we would want to physically test that the button works. This ensures that mechanically the RCD operates. An RCD test instrument is used to ensure that the RCD operates at the specific values that it's designed to. Say for example you plug into a socket. The reaction times are tested for different amounts of operating current at 50% load, 100% load and 500% load. And also different phases of the cycle, 0 and 180 degrees. Next we're going to talk about thermal cameras. They're great for spotting problems and even finding potentially cables in walls. Finally for today is the minor work certificate. No, it's not like the certificate you got in school for coming fourth in the 100 metres. This certificate is to prove that a new or altered circuit passes the test that we talked about before. Basically, giving the go-ahead to use that circuit or that addition. They should be given to the householder. At this point, I've finished my first book, which is nearly 400 pages long. I've also carried out some online learning, so I've covered quite a lot of material. The next book is on the side, staring at me to read and understand. I know some of what we looked at today will be done differently in different countries. I'd love to know how things are done where you live. Please let me know in the comments below. What's the equivalent of a minor work certificate where you live? Well, there we have it. Another week. Please like and subscribe. Battery Man out.